Welcome back, everyone. In this lecture, we're going to very quickly cover what sets are. And sets are unordered collections of unique elements. And this basically means that there can only be one representative of the same object. So you can't have the number 2 in there more than one time, or the letter A in there more than one time. Let's see some examples of how to work with sets in the Jupyter Notebook. To begin, let's create a set, and we can do that by saying my set, or whatever variable name you want, is equal to set, and then open and close parentheses. So right now we have my set, and it's just an empty set, so it returns back set. If we actually want to add an object to the set, I can say my set, and then call the add method, and we can add one object to this. So let's add the number 1. And now if I take a look at my set, I see it has the number 1 there. Now notice it looks like it's a dictionary because of these curly braces, but it's not because it doesn't have key value pairs. It's just unordered collections of any items you want. So let's add in another object here. We'll say my set, add in the number 2, and then if I call my set again, if I call my set, I get 1 and 2 there. Now let's try adding 2 a second time and see what happens. If I call my set, it still just shows 1 and 2. It doesn't show 1, 2, 2. And this is basically what a set is. It has to be unique values in there. If you try to add a value that's already in the set, it won't repeat it. It'll just say, hey, we already have that value in there. I only accept unique values. So when you're working with sets, it may not be super useful to add them in this manner. Instead, what it's really useful for is maybe casting a list to a set that we only get the unique values. So for instance, we'll say my list is equal to, and I'm going to place a bunch of repeated values in here. A bunch of 1s, a bunch of 2s, and a bunch of 3s. I'm going to run this, and then I'm going to cast this as a set, and now I get back only a set of the unique values. Keep in mind, sets don't technically have an order to them. Since we're dealing with very small sets here of just a few items, it looks like they have an order, but in reality, sets don't have any particular order to go in. For now, that's all you need to know about sets. We won't really touch upon this object or data type again until much later in the course. Since we're just beginning, it won't be very useful to us now, but later on we'll be able to see different use cases for it. Again, remember just that sets are unordered collections of unique elements. Thanks, and we'll see you at the next lecture where we discuss Booleans. Lecture, we're going to briefly discuss Booleans. Booleans, in case you're unfamiliar with this term, is basically a term to use for operators that convey either true or false statements. And these are really important later on when we deal with control flow and logic, because lots of times we want to check if a certain condition has happened. In other words, if a certain condition is true in order to execute some code. For example, you may want to check, hey, is my pool empty? If that is true, then go ahead and turn on the water to fill up the pool, or other things of that nature. So that's why Booleans are really important. And a lot of times we won't be dealing with Booleans directly in the terms true and false, but we'll actually have comparison operators and logical operators that return a Boolean value. So let's very quickly show you what these actually look like, and then we'll explore them later on in a lot more detail when they become more useful to us. Let's hop over to a Jupyter Notebook. Okay, so Booleans, there's true and false, and in Python you need to make sure that you have capitalized T in order for it to be true. Otherwise, if you have lowercase t, it's just going to complain, hey, you didn't define this term true because it thinks you're calling a variable. Instead, make sure that you have capitalized T, and it's the same for false. You're going to need to capitalize F for false. So here we have true and false, the main Booleans, and we can check their type by saying type, make sure I capitalize that T, type false, and it says BOOL for Booleans. And Booleans is what we're going to be dealing with when we're dealing with logical code. And a lot of times what we're going to be doing is working with comparison operators to create Booleans. And we're going to go over all the comparison operators later on in this course, but to show you a very simple example, there's comparison operators that check if something is greater than something else. So we can say, hey, is 1 greater than 2? So it's just a simple mathematical expression there. And it returns back a Boolean false. 1 is not greater than 2. And then you can do other things like check for equality with 2 equal signs instead of just a single equal sign. So is 1 equal to 1? Run that and it returns true. So these are called comparison operators, and we'll be showing you all of them later on in this course, but we first have to tell you what they actually are returning, which are Booleans. Alright, so those are Booleans, just simply true and false, and the type is BOOL. they'll be critical later on in this course. And finally, I want to mention that we can use the none keyword as a placeholder for an object that we don't want to assign yet. So maybe later on I want to assign B to something in my code, but for right now I just need to have a placeholder for it so I don't get this error of, hey, B is not defined. What I can do is say B is equal to none, notice the capital N there, and it's a none data type. And we've actually seen that before when we were dealing with in-place methods off a list. Remember that when we sorted a list in place, it returned back none, so when I type B here, I don't see anything out, but then what's nice is I also don't see that error of it not being defined. Okay, that's really the basics of Booleans. We're going to work on this a lot more later on in the course. I'll see you at the next lecture.